simple functions, rational functions. Here we go. The difference is, oh wait, these functions are a rational function with higher degree polynomials. Yesterday the degree was all 1. Now it's going to be 2 or 3 or whatever. Okay? That's what it means. That's the difference. All right, so I'm going to just take you right through the steps. Let me refresh your memory what degree means. Do you all know what degree means of a polynomial? It's the highest exponent, right? It's based on the highest or biggest, however you want to say it, exponent in the polynomial. Just so you remember what degree means, because I'm going to use that word a lot today. All right. So when you start getting these with degree bigger than 1, the x-intercepts. So we're going to look for x and y-intercepts today. Yesterday we didn't really do that. We just did asymptotes. Today we're going to find x and y-intercepts. Are the real zeros, means no imaginary numbers, of the top. So you set the numerator equal to 0 and solve. Okay? The y-intercepts of the graph are what you get when you plug in 0 for x. I'm going to practice all of these. So that's new. Now we're going to talk about the asymptotes. So basically the same thing. The graph has a vertical asymptote at each real solution of the bottom. You know what I mean. Of the bottom. You set the denominator equal to 0, just like before. You're finding out what makes that denominator 0. So that's the same, a vertical asymptote, whatever x can't be. These graphs are going to have 1 branch, 2 branches, 3 branches. They'll have all kind of funky things going on, depending on the power, the degree. These graphs have at most, sometimes none, 1 horizontal asymptote. They might have 1, they might not have any. It's determined by the degrees, using the rules in the table below. So you're going to be using these rules. Also in these graphs, the horizontal asymptote doesn't necessarily mean the graph can't cross that. It can't cross the vertical, but it might cross the horizontal. In pre-calc and calc, it's more kind of helping you, guide you with the end behavior of the graph. But I just want you to write that down. The graph may cross over the horizontal asymptote, and that's okay. All right, so these are the rules. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is a ratio of the leading coefficients, which is kind of like it was yesterday when we had a linear over a linear, same degree, you took a ratio of the leading coefficient, right? Same degree. All right, if the numerator degree is greater than the denominator degree, then there's no horizontal asymptote. If the numerator is less than the denominator degree, then it's going to be y equals 0. So kind of, if it helps you, I don't know if it'll help you, but if you think of it like a triangle, if the numerator is greater than the denominator, it's a top-heavy triangle. It's kind of tipsy. There's no horizontal asymptote. I don't know if it helps or not. Maybe. It helped me last year a little bit. If the degree of the denominator is bigger than the numerator, then it's a bottom-heavy triangle. And so y equals 0. I don't know. May not need that, but okay. Now let's just practice graphing following these guidelines here. So we got a few graphs to do because you're going to see different kinds. So here, the x-intercept is based on the real zeros of the numerator. So this is based on the top. So the numerator here is 3, so I'm going to set it equal to 0. Does that make any sense? No. So that means there's no x-intercept. The y-intercept of the graph are what you get when you plug in 0 for x. So I'm going to plug in 0 for x. And y equals 3/2. So that's my y-intercept. If that's written as an ordered pair, 0, 3/2. So let's plot that point. Y-intercept is 0, 3/2. The vertical asymptote is based on the bottom. It's whatever the bottom, x can't make it 0. So I'm going to say, all right, x squared plus 2 equals 0. Set it equal to 0. X squared equals negative 2. Can I stop? What's going to be the problem here? It's going to be an imaginary solution, because you can't take the square root of a negative number and have a real solution, right? So if I took it further, it would look like this, and that can't happen. Can't have an imaginary solution, so there is none. No vertical asymptote. Horizontal asymptote is based on this table. Is the degree, what's happening here? The degree of the what is bigger than the what? Yeah. The degree of the denominator is bigger than the numerator. So, degree, let's just do it this way. The degree of the top is less than the degree of the bottom. So which one would it be then? Yeah, it meets this right here, y equals 0. So let's sketch that. There's a horizontal asymptote at y equals 0. So all of that just to come up with some points and to come up with the asymptotes, whether there are or not. Then you choose points with respect to the vertical asymptote, where there is none here. But I know I'm probably going all the way across, so I'm going to choose some negatives and positives and see if I can get enough points to sketch this graph. So I'm going to do -2, -1, 0, 1, and 2. You will be able to use a calculator, so you can get them off the table. But you want to be careful when you're using your calculator that if you're plugging this in, you're going to put that denominator in parentheses. Or the calculator will do 3 divided by x squared and then add 2. So you got to be careful, okay? So I'm going to tell you what these points are. 1/2, 1, 1.5, which we already found. We already found that. And 1 and 1/2. So let's plot these points and look at it. It's kind of a funky graph. Wait. So that's kind of what you get there. Mine's a little low off there. Wow, it's a weird looking graph. Let's connect it. You know it comes really close to this asymptote but doesn't touch it. So that kind of helps you with guiding to draw it. And that's what it looks like. This is supposed to be the highest point here. I didn't sketch it very good. Isn't that cool?
So cool.
Don't turn the page because we have to talk about domain and range. All right, domain, what can x be in this particular graph? Anything. Yeah, it's based on the vertical asymptote, and there isn't one, so it's all reals. X could be anything. The range, now this is very limited. This is the highest point, and it's not going to go below that in this graph. So it's any real number that's greater than 0, but less than or equal to what? 1.5 or 3/2, however you want to write it. Okay? So there's one type that you'll see. Okay. All right, here we go. Let's start with the x-intercept, the top. Set it equal to 0. X squared equals 9. 9. Square root. X would equal plus or minus 3. Okay? As an ordered pair, that would be 3, 0 and negative 3, 0. So sketch those two x-intercepts. It's going to help you draw the graph. So I sketch those, okay? The y-intercept is plug in 0 in for x. When you plug 0 in for x, you pretty much just end up with this. And when you divide those, let's do it as a decimal, 2.25. That's not right. Yeah, it is. Okay. And then it's 0, 2.25. So let's put that point in. It's about right here. That's your y-intercept. Okay, let's see about vertical asymptotes here. Now remember that's based on the bottom. So I'm going to write x squared minus 4 equals 0. This is based on the bottom. X squared equals 4. X equals plus or minus 2. So this is your asymptote. So they're lines at positive 2 and negative 2. So I'm going to draw them. We've got two vertical asymptotes here. Horizontal asymptote. All right, look, they're equal, aren't they? The degree of the top is equal to the degree of the bottom. Just like yesterday when we had two linear, what did we do to get the horizontal asymptote? Do you remember? Yeah, it's just like when we had two linear. It's just 1 over 1. Y equals 1 over 1, so y equals 1. So I'm going to sketch a horizontal asymptote at 1. Okay? Okay, now, again, you have to choose points with respect to the vertical asymptotes. So we have to choose points here, we have to choose points here, and here, because they're going to be part of the graph on every part. So let's choose these points, negative 5, negative 3. That's to the left of that one asymptote. It can be negative 3. It just can't be negative 2. Oh, we already have. Yeah, I'm gonna show you. Yeah. Okay, that's in the middle. And then to the right is 3 and 5. So you just kind of look at your graph and pick points in relation to both of the vertical asymptotes. So if you went to your calculator, you would get this. We already got that one, negative 3, 0. That's fine. 2.67, 2.25, we already got that one as well. 2.67, 0, and 0.76. There's going to be 3 branches to this graph. Yep, so let's graph these points. Negative 5.76 and negative 3, 0. Oh, I went the wrong way. Yep, negative 3, 0. Okay, so if you need another one because you're not sure, you could always get another point. But this kind of looks like this when you graph it. It can't touch those asymptotes here. Okay, so let's do the middle one. Okay, and then over to the right. And that one happens to be symmetrical with the other side. Something like that. Okay? All right, what would the domain be? What can X be? It can be reals, but it can't be plus or minus 2. Okay, this one's a little tricky. You can tell here that the graph goes up to 1, but it doesn't touch it here. So I'm going to have 2 requirements for my range. It's got to be less than what? 1. But notice the lowest point here is at the y-intercept, which is 2.25. And they're also going to be greater than 2.25. So you kind of just have to really look at your graph. Okay? Or equal. You're right. Thank you, Alex. So just really look at your graph. Okay? All right, we got 2 more to do. All right, this one, notice that it's top heavy. It's top heavy. Is it going to have a horizontal asymptote? It won't, but we'll find that out. Okay. X-intercept based on the top. Oh, look at that. We have to factor. We got to factor that. Are you having fun yet? If this is 1, just look at the end. Factors of -3 that add to -2. So x equals 3 and x equals -1. Those are my x-intercepts. Intercepts, not asymptotes. So put a dot there and there. Okay?
Why do you change the graph?
Okay. Why do I change the graph?
Yeah.
Because we need more points here. It's bigger.
No, it's good. It's bigger. No, it's the exact same.
No, it's 10, whatever. Ignore that. Oh, no. Yeah.
Yeah.
It's all right. We'll just go up by 2s. Let's fix it. Let's fix it. Go up by 2s. We have to go up by 2s. We probably should. We should go up by 2s here. Just don't worry about it. That was from something else, and I wrote it in there. Okay. You can cross those off if you want. We'll go up by 2s. All right. So let's do the y-intercept. We plug in 0 for x. So if I plug in 0 for x, that's all going to go away, and y is going to be -3 over 2. So that makes it sort of like right here. Kind of yucky. Yeah, it's kind of yucky. All right, vertical asymptote. Again, we go by the bottom. We go the bottom of the fraction. X plus 2 equals 0, so x equals -2. Vertical asymptote. So I'm going to sketch a line here at x equals -2. I'm going up by 2s for those of you that weren't with me. Oh, what happened? Okay. Now, do the horizontal asymptote. What's going to happen there? The top is greater than the bottom, and so that tells me that there's what? There's no horizontal asymptote. So let's do some points, okay, with respect to -2. So I'm going to do -6, -4. We could do -3. And then we have our asymptote. And then I could do 1, 2, and 4. I'm just giving you some points that I got. So let's graph I'll give you the y coordinates. This. I just get them off your calculator. Just get them off your table. This purple line represents the asymptote. That's kind of why I put it there. Okay? All right, graph them. 2, 4, 6, and then 2, 4, 6, 8, 10, sort of here. It's kind of yucky. Yeah, it is. 2, 4, 6, 8, 10, 12. It's a funky one. It looks like this when you graph it.
Why?
Something like that. Your scale might be different. Yeah, your intervals. I went up by 2s. So, all right, let's do the top part now. Over 1 and up, down negative 1.3. It's kind of like right here. And then 2, negative 0.75. Those are really close together. And then 4.83. Looks kind of like this.
Holy cow, Lisa.
Something like that. It is. I told you, they're funky. The top. Let's get the x-intercept off the top. When you solve that, you're going to get x equals 0. So your x-intercept is 0, 0. So let's put a point there. The y-intercept, you plug in 0 for x. Plug in 0 for x, and you get y equals 0 over negative 16 when you plug in 0 for x. So y just equals what? 0. And we already got that point. We already put the point there. Okay, vertical asymptote is based on the bottom again. X squared minus 16 equals 0. X equals plus or minus 4. Nope. 1, 2, 3. Okay, there's your asymptotes. You notice the degrees are the same, so it's the ratio of the leading coefficient. Y equals 3 over 1. 3 over 1. So y equals 3. So I'm going to draw a line here. So you have to do some points to the left of your asymptote. The left of the left one. And then inside the middle one, which you already have some of these. And then to the right of the right one. And I'll just give you those numbers. 7.2, 8.33, negative 1, 0, we already did that one, negative 1, 8.33, they're symmetrical. And then graph. These are flipped. I did them wrong. Don't look at me. I know. I always do it right when I do it here, and then for some reason on here it's harder when you're doing it in front of everybody. Okay. Then negative 2, negative 1, 2, negative 1. This one goes like this. And then it's kind of symmetrical over here, so just kind of do the opposite of what you did over there. There you go. Isn't that beautiful?
That was so fantastic. I had so much fun.
We do have to talk about domain and range. Okay, the domain is all reals, but can't be what?
Negative plus or minus 4.
Right. And the range is all reals. These do keep going, so it's all reals, just greater than 3. This one doesn't go any higher than what?
0.
0. Less than or equal to 0.
That's true.
Okey-dokey.